Hello everyone, it's Anita Shara. I'm here to give a seminar on the topic of linked list. As you all know a little bit about the linked list, let us talk about some detail. Linked lists are the fundamental data structure that offers flexibility and efficiency in managing dynamic data. The form the foundations for many complex algorithms and applications providing a dynamic approach to storing and accessing information. Uh,
Now let's understand the basics of linked list. Linked list structure. Linked lists are linear data structure, meaning that elements are arranged in sequential order, to similar to arrays, where each elements or node contain both data and reference to the next node in sequence. Unlike array, linked lists do not have a fixed size and grow or shrink dynamically by adding or removing nodes. Linked lists are foundation in data structures and they comes in several types that we are going to discuss in the types of linked list. That is another thing is dynamic allocations. Unlike array, linked list can grow and shrink dynamically, accommodating varying amounts of data. Node connections. Each element called a node contains data and reference or a pointer to the next node of the list. Now let's discuss about the anatomy of linked list node. A node is the fundamental building block of a linked list. Each node holds a data and the link to the other nodes, enabling the list to form a sequence like data. This part stores the actual value or information. Example: an integer string object that the node represents. Data can be of any type depending on what the list is meant to store, and that is only given. This could be a number, string, or even a complex object. Pointer or link to the next node. Pointer is also known as a link to the next node. This is the reference to the next node in sequence. In single linked list, this pointer only points only the next nodes, but in double linked list, there is a pointer also contains the additional pointer containing the previous node. This enables the bidirectional traverses in list. Now let's continue by traversing and manipulating linked list. What does traversing in linked list means? Traversing means visiting each nodes in the linked list sequentially, starting from the head and moving to each subsequent node until the end of the list. What is the purpose of traversing in linked list? Traversal is essential for performing operations like searching for elements, displaying the list, or performing calculations on nodes value. Uh, all the steps to how to traverse a linked list steps. Now we're going to discuss about the steps. Start at the firstly starting point. Beginning at the head nodes, the first element of the list. Visit each nodes. For each nodes, perform any necessary operation. Example: we can print data, check conditions, or source data. That's the any operation can be done. Then after to complete completion of the operation, then move to the next nodes. Use the pointer in the current node to move the next nodes, which is stored in the pointers. As we discussed previously, that nodes of a linked list consist data and pointer contain the address of the next nodes. So by using that pointers, we can move to the next node. Int at the last node. It ended and the operation ints at the last node continue until reaching a next node where the next pointer is null. If you find the next pointer is null, then int at the last node. That is the traversing of linked list. Manipulation of linked list involves linked list common linked list operations like insertion, deletion, searching, and reversing node within the linked list. That is called traversal. That is insertion, adding a new node at a specific position. Insertion is of three types. That means it is not at three positions. That is insertion at the beginning, add a new numbers at the new head. At the end, traverse the last node and link the new node to it. That is known as insertion at the end. At a insertion at a specific point, traverse the desired position and adjust pointer to insert the new nodes. That is the insertion at the specific point. Another operation is deletion. Deletion means removing a node from the list. Deletion is also three types of deletions can be done, like deletion from the beginning. That means remove the head node and make the next node the new node. That is known as deletions. from the beginning, deletion from the end. Another one, traverse to the next last node and set it next to the null. That means if the pointers detect the nulls, that means it into the linked list. Another one is from a specific point, deletions from a specific point. That means traverse to the node before the one to be deleted and adjust pointer. That's all. A travel visiting is noticed in a list sequentially. That is that is the operations, deletion operations. Another operation is searching. Searching is what the purpose of searching? Finding a node containing a specific value. That is searching. Searching steps. What are steps can be done for the searchings? So traverse each node, checking the data as each node. Return the node or index if the found, null if not found. That can be done traversing. Another person can be also reversing a linked list. Reverse a linked list which is only on in double linked list. What are the purpose of reversing a linked list? Change the order of nodes so that the last nodes become the head and each node points to previous one. What are the steps? Reversing a linked list. Initialize pointer to track current, previous and next node. Traverse through the list, reversing each next right pointer. Summary. Let's some discuss about the summary of manipulations operations or common linked list operations. Insertion: add a node at the beginning in our specific positions. That is known as the insertions. Deletion can be done in three ways. Same as remove a node from the beginning into a specific position. Search is another operation which can be done. Find if a value exists in the list. If found, then print found. If not found, then print not found. Another operation is reverse. Change the list order by reversing pointer. The traversal manipulation techniques are foundational for working with linked list and understanding how data is managed dynamically in memory. That's are the common linked list operations. Advantage and disadvantage of linked list. Advantages of linked list are dynamic size. Like linked list do not require a predefined size unlike arrays. They can grow or shrink in size as needed, making them ideal for applications where the amount of data is unpredictable. Useful in situations where memory needs vary, such as dynamic data structures, example stacks, queues, and graphs. What is dynamic size? Another one is efficient insertion and deletions. Linked list allows for efficient insertions and deletions, especially at the beginning or end. Adding or removing element does not require shifting other elements as is necessary in array. As if we are removing any element from the array, we have to shift all the previous data to the previous one. But we don't have to do in the linked list because we are going to delete a certain nodes. Applications like real-time systems or cache where frequent additions or removals of elements are required, no wastage of memory. Flexibility in representations of data structure. That are the advantages of linked list. What disadvantages of linked list are increased memory usage or memory overhead. Each node requires additional memory pointers, which increases the overall memory consumptions. Drawback: the extra money overhead can be significant, especially in large list of environment with limited memory. For small data sets or systems, the limited memory areas can be. Another one is sequential access or random access. Linked list do not support direct access to the elements as array do. To access or modify a particular element, traversal from the head nodes is required, resulting in big of an access time. That is which is another disadvantage: complexity in implementations, cache unfriendliness. Are the disadvantages and advantages of linked list. Linked list variations and specialized applications. Linked list first one is single linked list, the most basic types with node pointing to the next node only. There is only one node which points to the previous next node, not to the previous node. Another one is double linked list. Yeah, we can see that the first one in the line is known as single linked list. Another one is the red and blue are known as double linked list. In double linked list, each node contains pointers to both the next and previous node, allowing for the bidirectional traversal. That is by double linked list. And the last one is circular linked list. Circular linked list, you can say that the round one is known as circular linked list. The tail nodes pointers points back to the head nodes, creating a closed loop that are the linked variations and specialized applications of linked list. To optimize linked list performance and memory usage while incorporating data caching, data compressions, and garbage collection. Data caching. Implement a kits for required access node to reduce traversal times, especially in large lists. Use technique like list. They simply use LRU caching for commonly accessed nodes. Another one is data compression. Data compression compress data within nodes if they hold large or repetitive data. Use lightweight compressions algorithm to reduce memory throughput, especially if nodes contain strings or sizable data chunks. Another one is garbage collection. Garbage collection uses a custom memory pool for node allocation to prevent fragmentations and simplify garbage collections. Periodically clean up unused nodes or use weak reference to allow garbage collection of nodes no longer in use. That is all regarding the seminars on the topic of linked list. Thank you for giving your time.